Just wanted to do a few more examples of proofs on a coordinate plane to show the difference between using the sides of the quadrilateral and using the diagonals. So the first one I'm going to do is number 1 on page 6. I'm going to use the sides first. You can see with the sides I can look at the side lengths and the slopes. For the side lengths I'm using the distance formula if they're diagonal, or just subtraction if they're horizontal or vertical. So AB and DC are both just horizontal with a length of 7, so those are congruent. DA and BC both go over 3 and up 8. That gives me a distance of square root of 3 squared plus 8 squared, which is square root of 73. So these two are congruent as well. So the opposite sides are congruent. It's a parallelogram, but not all the sides are congruent, so it's not a rhombus. So from that alone, we can just tell it's a parallelogram. On the other hand, we can look at the slopes. AB and DC are just horizontal, so their rise over run, their rise is 0. It's not going up at all. 0 over 7, which is just 0. So these two are parallel. DA and CB are both, again, going up 8 over 3. That's a slope of positive 8 over 3 in both cases, so these two are parallel. So the opposite sides are parallel. That means it's a parallelogram by definition. But notice these are not opposite reciprocals, so the consecutive sides, like DA and AB, or AB and BC, are not perpendicular, so it is not a rectangle. So it's not a rhombus, it's not a rectangle, so the most we have been able to say it's a parallelogram. So that's what we're going to go with. ABCD is a parallelogram. On the other hand, I could have used my diagonals and reached the exact same conclusion, but using different properties, using the diagonals properties. You don't have to do both. This is an either or. In fact, you can mix and match between, you could say use the sides to show it's a parallelogram and then use the diagonals to test whether it's a rhombus or a rectangle. It's whichever works for you. So looking at the diagonals, the way you tell if it's a parallelogram is if the diagonals bisect each other. They bisect each other, the midpoint of the two diagonals should be the same point. So to get the midpoint, I add together the x's, divide by 2, add together the y's, divide by 2. So the midpoint of AC, I add this x to this one, divide by 2, and I add this y to this one, and divide by 2, and I wind up with 0, 4. If I go through the same procedure for DB, again I get 0, 4. Since these midpoints are the same, these two diagonals meet at the same point, which is the midpoint of each, so they bisect each other. So it's a parallelogram. But to be able to tell if it's anything else, I have to look at the properties of rhombuses and rectangles using the diagonals. The diagonals of a rhombus are perpendicular. The diagonals of a rectangle are congruent. If I use the distance formula to get the length of these two lines, AC goes over 4 and down 8. That's distance formula gives me 4 squared plus 8 squared, square root of 80. If I do the same thing for DB, well, we can visually see it's longer, but you can also plug into the distance formula and we get a different answer. We get square root of 164. So the diagonals are not congruent. It's not a rectangle. So from just the midpoint and the distance formula, we know it's a parallelogram, not a rectangle. We can check whether or not it's a rhombus by checking the slopes of the diagonals. Remember, if they are perpendicular, which it looks, looking at the graph, it could be. But we have to actually check the slopes to see. So if we look at the slope of AC, this is going down 8 over 4. Slope of negative 8 over 4, which is negative 2 over 1. But if I look at the slope of DB, it's going up 8 over 10, which reduces to 4/5. These are not opposite reciprocals, so this is not perpendicular, so it's not a rhombus. So again, we know it is a parallelogram, we know it's not a rectangle, it's not a rhombus, so we're going to just go with saying it's a parallelogram.